We are going to work an example that will produce the final answer of being plus infinity, minus infinity, or does not exist, dne. These are called infinite limits. In this particular structure, what you will see is a number divided by 0, and the numerator is not 0. So with any limit, the first thing we do is we plug in x equals a, and we see what happens. So 3 plus 2 over 2 minus 2 is 5 over 0. We see a non-zero number in the numerator and we see 0 in the denominator. And this tells us that our final answer is going to be either plus infinity, minus infinity, or does not exist, dne. To decide which case we're in, the technique that we're going to need is one-sided limits. So to decide, we need one-sided limits. So we first need to evaluate the left side or the right side. I'll do left first. So this is left, and then right. And then we will decide between the three choices, plus infinity, minus infinity, or dne. To test this, the way I recommend that we do this is just plug in the a, but this time we're going to actually have to do a little bit of thinking. So 3 plus 2 minus. So what does 2 minus mean? That means it's a number kind of like 1.9, 1.99, 1.99999, something like that. And we're going to plug that in for x. Now on the top, if it's a number like 1.9999999, then we add 3, then it's going to be a little bit less than 5. And in the denominator, a number like 1.9999999 minus 2, well, that's going to be close to 0, but it's going to be negative. Again, 1.9 minus 2 is negative 0.1. 1.99 minus 2 is negative 0.01. So if we plug in numbers that are close to 2 but a little bit less, and then we subtract 2, we'll be close to 0, but we'll be a little bit less. Now, I call this negative 0, which sort of doesn't make sense, but you can make sense of it if you think about it. 5 with that minus upstairs is kind of like a 4.9, 4.9 is a bunch of 9s going to however many 9s you want. That's positive. And we're dividing by negative 0.00, as many zeros as you want, and then a 1. And when you do that calculation, you're going to end up with the positive divided by negative is a negative result, and it's going to be quite large. So negative infinity. So I encourage students to think about a positive number divided by 0 minus is negative infinity. Now we'll do the right side limit and we'll see what happens. Again, we just plug in the 2 plus, and we'll see what happens. In the numerator, we get a little bit bigger than 5 because 2 plus is a number kind of like 2.1 or 2.01 or 2.001 or something like that. So it's a number a little bit past 5, but not much. With the 2 plus minus 2 downstairs, that's going to be just a little bit positive. So I'll call that 0 plus or positive 0. And here, we're sort of thinking of this as 5.001 divided by 0.0, a bunch of zeros and a 1. And when you do that, you're going to get a positive divided by a positive, which is positive, and you're going to get positive infinity as your result. So I often tell students to think of this as positive number divided by 0 plus is equal to plus infinity. These are things you think, but you don't really write down, but you can think it. Now, what does all of this mean? Well, these two here are different. These disagree. They're not the same. And because they disagree, the final result is dne. So when we go back to the original problem, the answer is dne because the left and right side do not agree. If you're curious what this means graphically, this is like a vertical asymptote on a rational function. where you have at x equals 2, on the left side the function plummets to negative infinity, and then on the right side the function blows up to positive infinity. And then, we don't know what else is going on with that function, but right there at the vertical asymptote, they get torn apart in opposite directions. The limit does not exist. Now this next example is nearly the same as the previous one. We'll just change it very slightly, and we'll see what happens. We evaluate the limit as x goes to 2 of 3 plus x divided by the quantity x minus 2 squared. We're just going to see what the effect of squaring the denominator is. Again, we plug in the a, see what happens. 3 plus 2 over 2 minus 2 squared. We get 5 over 0 squared, which is 5 over 0. We see this number divided by 0 where the numerator is not 0. So there's one of three cases. It's plus infinity, minus infinity, or DNE. When we see this number divided by 0, our technique is one-sided limits. So we need a left and a right. The left side is the minus. And the right side is the plus. Again, we just plug in the a with the minuses and the pluses, and we take care with the reasoning, work out the details carefully in our minds. So the 2 minus goes in. Now 3 plus 2 minus is 5 minus. And in the denominator, the 2 minus minus 2, so this is just left of 2, like 1.9, minus 2 puts us just left of 0, so we have negative 0. And when we square negative 0, the negative will go away with the square, and we're left with 0 plus. And here we have a number that's sort of like 4.999 divided by 0.01, and that result is plus infinity. Compare this to what we had in the previous example, where we had a number just left of 5 divided by negative 0. The result is negative infinity. Down here, we have just left of 5 divided by positive 0, resulting in positive infinity. When we try the right side, we're going to see 3 plus 2 plus is 5 plus. And then 2 plus minus 2, so 2 plus is like 2.1. 2.1 minus 2 is 0.1, so that's 0 plus. And we have to square that. 0 plus squared is, well, that's just 0 plus again. So this is sort of like 5 zeros and then a 1 divided by 0.0001. And that's positive divided by positive is positive infinity. These two are the same. And what we can conclude from that, because they're the same, is that the original limit as x goes to 2 of 3 plus x over x minus 2 squared is equal to plus infinity. So if they agree, we conclude that the limit is the same as what they agree with. So if they were to agree with minus infinity, we would say that the limit is minus infinity. And if they agree with plus infinity, then we say the limit is plus infinity. If they do not agree, it is DNE.